What if Earth suddenly stopped spinning? Right now. Not slowly. Not over time. Instantly. At first, it might feel like nothing has changed. But in reality, everything depends on that motion continuing. And the moment it stops, physics takes over in the worst possible way. Right now, you are already moving with the planet, even if you feel completely still. At the equator, Earth is spinning at about 1,600 kilometers per hour. That's faster than a commercial jet. But you don't feel it, because everything around you is moving at the same speed. Air, buildings, oceans, even you. Now imagine that motion disappears instantly. Earth stops, but you don't. This is where inertia becomes dangerous. Inertia means objects keep moving unless something stops them. So everything on the surface continues moving east at full speed. Cars, trees, people, entire cities. In a single moment, everything is thrown forward at extreme velocity. There's no warning, no delay, no chance to react, but here's the problem. It gets worse than just solid objects. The atmosphere is also moving with Earth. And when the planet stops, the air does not stop instantly. It keeps moving at the same speed. This turns the entire atmosphere into a global shockwave. Not a storm, not a hurricane. Something far beyond that. Winds would exceed the speed of sound. Imagine the entire planet being hit by a continuous invisible wall of air. Buildings collapse instantly. Forests are stripped away. Entire landscapes are reshaped in seconds. And then comes the oceans. Water is also in motion. And when Earth stops, the oceans don't stay still. They continue moving forward. Massive walls of water surge across continents, erasing coastlines almost immediately. So ask yourself, what would actually survive the first minute of this event? Because this is the shocking part. Everything you've just imagined is only the beginning reaction. The surface is just responding to the stop. But deeper changes are already starting to build. And once everything on Earth is forced into motion, something far more destructive begins to unfold next. The moment Earth stops spinning, you don't. Everything around you is still in motion, fast. Faster than a jet flying at cruising speed. And that raises a terrifying question. What happens when an entire planet suddenly loses its brakes? When Earth stops, inertia takes control instantly. And inertia does not care about life, structures, or stability. Right now, at the equator, you are already moving east at about 1,600 kilometers per hour. That's faster than a commercial airplane. But here's the problem. When the ground stops, that motion doesn't stop with it. Everything not firmly anchored to solid bedrock continues moving forward. Cars are thrown across roads. Buildings begin tearing apart under sudden force. Loose objects turn into high-speed debris instantly. Even the ground itself fractures under the stress of rapid deceleration. But the real destruction is not what you can see. It's what you can't. The atmosphere. The air around you is also moving at the same speed as Earth. And when the planet stops, the air doesn't stop with it. It keeps moving. At over 1,600 kilometers per hour. That's faster than the strongest hurricanes ever recorded. But this isn't one storm. It's the entire planet. Imagine standing inside winds like that. It's not just strong gusts. It's continuous atmospheric impact. You would be lifted, pushed, and overwhelmed instantly. Cities would collapse within minutes. Forests would be stripped from the ground. Even structures built to survive earthquakes would fail almost immediately. And then comes something even more powerful. The oceans. Water does not stay still either. When Earth stops, billions of tons of ocean water continue moving forward. This creates mega tsunamis. Walls of water hundreds of meters high. They would crash into continents, move deep inland, and erase entire coastlines. Entire regions would disappear beneath the water almost instantly. But here's the twist. This is not just a surface disaster. What is happening above ground is only part of the picture. Because while land, air, and oceans are collapsing together, something far more important is shifting beneath all of it. And that shift changes everything about how the planet behaves next. Imagine the oceans starting to move. Not as waves, but as one massive shifting system. No wind, no storms, just water, responding to a planet that has lost its balance. And now ask yourself, Where does all that water go when Earth stops spinning? Right now, Earth's rotation is doing something you never notice. It is keeping the oceans evenly spread across the planet. Because of that spin, water is slightly pushed outward near the equator. This is called centrifugal force. It helps the oceans stay balanced in their current positions. But the moment Earth stops spinning, that force disappears instantly, and gravity takes full control. Now the oceans begin to move. Not randomly, but in a very specific direction, toward the poles, where gravity pulls more directly inward. At first it sounds slow, even manageable. But here's the problem. We are talking about billions of tons of water. When that much mass starts moving, it does not stay gentle for long. Water levels around the equator begin to drop. Coastlines start retreating faster than anything seen in normal tides. Entire regions that were once underwater suddenly begin to emerge. Imagine standing on a beach and watching the ocean physically pull away from you. Not because of wind, not because of climate, but because the planet itself has changed its structure. But while equatorial regions are drying out, something extreme is happening elsewhere. Toward the poles, water is building up, and not just a little. It becomes a deep, crushing accumulation of ocean mass, far beyond anything we observe on Earth today. Cities near the polar regions would be submerged completely, not flooded slightly, fully erased under hundreds of meters of water. Entire landscapes disappear beneath a new ocean layer. And here's the twist. This is not just water moving around. It is a complete reshaping of Earth's surface. A planet that was once balanced becomes completely reorganized. Some continents rise out of the water, like exposed ancient ruins. Others disappear entirely beneath new oceans. But even this dramatic transformation is not the final stage. Because while the oceans are still shifting into their new positions, something far deeper inside Earth is beginning to react to the sudden change in balance. And that reaction will reshape everything we think we know about the planet. What if the sun stopped rising for half the planet? Forever. No sunrise, no sunset. Just a fixed reality locked in place. One side of Earth in endless daylight, the other in permanent darkness. It sounds impossible, but this is exactly what happens if Earth stops spinning. Right now, Earth's rotation is what creates day and night. As the planet turns, different regions move into sunlight, then out of it. This rotation creates a stable rhythm, and nearly every living system on Earth depends on it. But if Earth suddenly stops spinning, that rhythm disappears instantly. One side of the planet faces the sun continuously. The other side is locked away from it. And this is where the real extremes begin. On the daylight side, the sun never moves across the sky. It stays fixed in one position. At first, it feels like endless afternoon. But then something changes. Heat begins to build up. Because there is no rotation to spread energy around the planet, sunlight keeps pouring into the same regions. Land heats up continuously. Oceans warm without relief. The surface begins to behave like a sealed container, absorbing constant energy. And here's the problem. There is no natural cooling cycle. Now shift to the dark side of Earth. No sunlight ever reaches it, no warmth, no energy input, nothing, but only endless night. Temperatures drop quickly. Then they continue dropping over time. The ground freezes, ice spreads, air becomes dense and still. It is like two completely different planets sharing the same world. And here's something even more disturbing. Between these two extremes lies a narrow transition zone, a thin strip where conditions are not fully extreme, not hot enough to burn, not cold enough to freeze instantly, just barely survivable. But this zone is extremely limited. Imagine being forced to live in a narrow band of Earth while everything above you becomes overheated and everything below you becomes frozen. But the instability doesn't stop there. With no rotation, Earth's weather systems collapse. There is no spinning force to move air around the planet. No mechanism to balance heat distribution. Storms become erratic. Climate patterns break down completely. And suddenly, survival is no longer about countries or borders. It becomes about location on a planetary scale. Whether you are on the hot side, the cold side, or the narrow middle, determines everything. But even this divided Earth is not stable for long. Because the atmosphere itself is about to begin changing in ways no one would expect next. What if the air around you stopped behaving the way it should? No steady winds. No predictable weather. No stable climate. Just an atmosphere that still exists, but no longer works properly. This is what happens when Earth loses its rotation. Right now, the atmosphere is constantly in motion, and that motion is driven by one major force, Earth's spin. As the planet rotates, it creates a natural system. Warm air rises in some regions, cool air sinks in others. This difference generates wind. It drives weather patterns. It powers global air circulation. Think of it as an invisible engine running the entire atmosphere. But when Earth suddenly stops spinning, that engine shuts down. At first, nothing seems different. You can still breathe normally. Oxygen is still in the air. Nitrogen is still stable. For a moment, everything feels familiar. But here's the problem. Nothing is being balanced anymore. On the permanent daylight side, the air keeps heating up. Warm air becomes lighter and rises continuously. On the dark side, the opposite happens. Cold air sinks, becoming dense and heavy. This creates massive pressure differences across the planet, and nature always tries to correct imbalance. So air begins rushing between hot and cold regions. But this is not like normal wind systems. This is a planet trying to stabilize itself without rotation. Instead of smooth circulation, the flow becomes unstable. Air starts moving in extreme, uncontrolled patterns. Imagine constant atmospheric movement from one side of Earth to the other. Not breezes, not storms as we know them, but planet-scale wind systems with destructive force. Along the boundary between hot and cold zones, massive storm systems would likely form. A permanent chaotic weather belt wrapping around the planet like a scar. And here's something unexpected. Not every region becomes violent. Some areas might become almost completely still. No wind, no weather movement, no change. At first, that sounds peaceful, but it's not. It's stagnation. Trapped air with no circulation or renewal. And this imbalance only grows stronger over time. Because without rotation, there's no mechanism to distribute energy evenly anymore. Weather stops being a cycle. It becomes a direct reaction to extreme conditions. And as the atmosphere collapses into this unstable system, something even more important begins to shift. Because even if the air is still breathable, the environment it creates is no longer stable for life. And that leads to a much bigger question. How long can anything survive inside a planet that no longer knows how to balance itself? If Earth suddenly stopped spinning, would humans actually survive? Or would this be the moment civilization reaches its limit? The surprising answer is not a simple yes or no. It depends on one thing: location and adaptation speed. At this point, Earth is no longer the planet we recognize. One side is locked in permanent daylight, constant heat, no pause. The other side is trapped in endless night, deep cold, no sunlight at all. And between these extremes, there is only a thin transition zone, a narrow band where conditions are barely stable enough for life. This area is called the twilight zone, and it becomes the most important place on Earth, because it is the only region where temperatures are not completely lethal. Think of it like a border between two collapsing worlds. On one side, heat builds up like an oven that never turns off. On the other, cold deepens like an ice age frozen in place. But in the middle, conditions are just barely survivable. So naturally, humans would move toward this strip of land. But here's the problem. Everyone else would too. Now imagine billions of people concentrated into a shrinking habitable zone. Cities would become overcrowded almost instantly. Food, water, and shelter would turn into critical survival resources. Competition would not be optional. It would be constant. And then comes the bigger issue: food itself. Without a normal day-night cycle, ecosystems begin to collapse. Plants depend on rhythm. Light and dark cycles guide their growth. But now that rhythm is gone, agriculture starts failing across the planet. What if entire harvests stopped producing enough food? What if large regions simply became unusable farmland? At this point, humanity turns to technology. Greenhouses, artificial lighting, controlled environments. These systems could keep food production alive, but they require massive energy input. And energy systems are already under extreme pressure, so technology does not solve the crisis. It only slows it down. Meanwhile, nature outside human control begins to break apart. Animals lose migration patterns. Pollination systems fail. Entire food chains start collapsing. And yet, humans remain adaptable. We always have been. Vertical cities could rise in the twilight zone. Underground habitats might expand. Artificial ecosystems could replace natural ones. But survival no longer feels like living. It feels like constant maintenance against collapse. So yes, humans could survive this world, but only by changing almost everything about how civilization works. And just when adaptation seems like enough, a deeper question appears. Because surviving a broken planet is one thing, but surviving the loss of balance itself is something entirely different. We've seen oceans shift, we've seen winds collapse, and we've seen life struggle on the surface. But what if the real transformation is happening far beneath your feet? Deep inside the planet, where no human can see, and where changes happen on a completely different timescale. So the question is simple. If Earth stops spinning, does the planet itself begin to change from the inside out? To understand this, we need to look beyond the surface. Earth is not a solid, unchanging rock. It is a layered system, a thin crust on top, a thick mantle underneath, and a molten core at the center. All of it constantly interacting. And right now, Earth's rotation quietly helps stabilize that system. Because as the planet spins, it creates a balance between outward centrifugal force and inward gravity. That balance is one reason Earth is not a perfect sphere. It is slightly wider at the equator and flattened at the poles, a shape that has existed for billions of years. Now imagine that spin suddenly disappears. At first, nothing inside Earth reacts immediately. Gravity still holds everything together. The core is still molten and moving. The mantle still flows slowly. But here's the problem. Equilibrium begins to shift over time. Without rotation, the equatorial bulge is no longer supported. So, extremely slowly, the planet begins to relax into a more perfect sphere. Not in days, not in years, but over thousands or even millions of years. And that sounds harmless at first, until you realize what it actually means. Because when a planet changes shape, its mass distribution changes too. Land masses adjust, oceans redistribute, internal pressure zones shift like a slowly deforming structure. It's similar to a water balloon that has been stretched for a very long time. Once you stop the force holding it in shape, it begins to settle differently. And here's a surprising fact. Gravity itself does not disappear, but it can vary slightly depending on how mass is distributed. So as Earth slowly reshapes itself, tiny gravitational differences could emerge across the surface. Barely noticeable, but real. But here's the deeper twist. The core might also respond. Earth's magnetic field is generated by movement in the molten outer core, and that movement is influenced by rotational dynamics. So without spin, that magnetic system could weaken or behave unpredictably over long timescales. And that matters, because Earth's magnetic field protects us from harmful solar radiation. So even if the surface seems stable, something invisible is quietly changing deep inside the planet. Slow, silent, structural. And that leads to a disturbing question. If even the shape, gravity, and internal systems of Earth begin to shift, then what exactly is Earth supposed to be when everything finally settles into a completely new balance? So if Earth stopped spinning, what would the final outcome actually look like? Would it be instant destruction? Or something far more slow and far more unsettling? Because the real danger is not one single disaster. It is everything collapsing at the same time. At this point, we've seen extreme winds. We've seen oceans shift across continents. And we've seen ecosystems pushed beyond their limits. But if you step back, a pattern appears. There is no single ending moment. Instead, there is a chain reaction. One system fails, then another after that. Earth is not a collection of separate systems. It is one connected machine. The atmosphere depends on the oceans. The oceans depend on temperature balance. Temperature depends on sunlight distribution, and all of it is indirectly stabilized by Earth's rotation. So when rotation stops, nothing breaks alone. Everything destabilizes together. Here's something surprising. Earth is one of the most balanced systems we know of. Not because it is perfect, but because every imbalance is constantly corrected by another process. It is a system built on compensation, but here's the problem. That only works while the system is moving. Once rotation disappears, those compensations begin to fail. Slowly at first, then all at once. What if global wind systems never return to normal? What if oceans never redistribute heat properly again? What if ecosystems are forced to rebuild under completely new conditions? Each problem doesn't stay isolated. They stack. They interact. They amplify each other, like falling dominoes that never stop once they begin. And this is what makes this scenario so powerful. It is not a sudden explosion of destruction. It is the slow unraveling of stability itself. Now here is the twist most people miss. Earth would not become completely lifeless immediately. Some regions might still support life for a while. Some systems would continue functioning in isolation. But the planet would no longer operate as one unified system. And that is the key realization. We don't live on a fragile planet. We live on a finely tuned system. A system that feels stable only because everything is working together at the same time. You never notice it when it works. You only notice it when it breaks. And maybe the real question is not what happens to Earth, but how something this complex stayed balanced for billions of years, without us ever realizing how precise that balance really was. Because once you truly understand that, you start to see the planet differently. And that leaves one final question hanging in the silence of space.